relies on, if I call the constructor to new function, it produces a random one. It needs to be able to do replace, mutate, count.
So we have to make it replace and mutate.
Yes.
What is mutate right there?
What is it?
Like 0.05?
It is a 5% chance of changing some of the numbers.
The constants, not the...
Just the constants, right.
Yeah.
That's when it actually turns the function into ninja mathematical teenagers.
Mutate. Oh. Seems pretty outdated.
I didn't get it. So if we were to mutate this function here, we would go through and
change just the numbers?
Just the numbers. So each one of the numbers has a 5% chance of changing itself to something else.
Why only 5?
You just want a slight mutation.
Yeah.
You don't want a completely different function.
So could it then go through and none of the numbers change?
Some of the numbers might not change, right? That's the nature of mutation, right? Sometimes nothing changes. But you could fiddle around with that number, make it a 50%.
They're just living in Chernobyl.
There's one part where I generate 20 where I just mutate the numbers, but they have a 30% chance of changing. That's when we run it, you'll see that eventually you get kind of one that's pretty good, and then a whole bunch that are really similar. They kind of follow the same track, but just maybe they turn slightly differently. That's probably that, where it's just changing the numbers, but it's following the same general things. You see a whole bunch that are doing pretty much the same thing. So the idea is that these are pretty good. Maybe we just need to tweak them a little bit, get it better. So they go a little bit further, or they stop a little bit before. Nowhere in the stage does it have to know exactly what these individual functions are. It doesn't have to know that there's tangent or log or add in there. It just says make me a new function, mutate it, replace stuff. So you have the ability to go and decide what are the actual operations you want to support. Wow.
That was getting crazy.
I like this one. What'd you change?
Everything.
Nothing?
Nothing and everything.
Apparently.
That's
Found
a
it- Found it after only 5 generations, too.
Wow.
What did he change? Orangey.
So it starts from that left tip and goes all the way around, up and back down.
Change
Crazy
my-
stuff happened.
Heading right toward it. Oh, I'll just go around it. Oh, heading right toward it.
It'd be nice if you had
Oh.
showed all 4 of the best functions and see it.
What's that?
It'd be nice if you showed all 4 of the best functions.
Well, it is actually the best one. This one here
Yeah.
is just this one.
I know it would be interesting to see the 6 and the 4, all.
Oh, I see.
Because they're all under 10.
Yeah.
So
So
they're
they
all, technically, they all 4 of those hit it. I just want to see if they hit it in different ways.
do. Well, you could do that. Where is it?
It's somewhere.
Right here, I think. Yep. This one here is just displaying the best one.
Mm-hmm.
Run through the loop and display all of them. Give it a different color.
Yeah, each one's different color. Duration 0. Really?
Before we do that, where would I change where the targets are?
Somewhere where it says targets.
Look through this list of stuff.
Set targets.
Set targets?
For you.
Change those values.
Hmm?
Change those
values.
values.
So I was thinking, it starts out in the middle and it's pointing to the right. What if we put all the targets behind it?
Do it. Won't you just turn around so it gets a bearing on its little compass that you made?
I don't know.
You'll just do circle till it finds them.
Wouldn't it be easier just to turn around which way it starts going? Or can you do that?
Yeah, that would be giving them, that would be giving them instinct. They don't have instinct.
What are you talking about? They're turtles. They're loaded with instinct.
Well, no, I mean, if it's, like, in the example, it was don't start going to the right somehow. You know, make it so it starts going out on the left instead.
Plus, they got the moon to help them.
And part of the reason why it goes to the right by default is when you ask it to turn, it's a right turn by default. You could just change it to left, and then it will turn left by default. In fact, you could have somehow could randomly turn, or you can somehow store in there whether it's a left turner or a right turner. Okay, so let's put all the points behind it.
I thought it turned because of the value that you're giving it.
Right, and actually, if you give it a negative number, it turns left. And in my functions, I think positive numbers and negative numbers are neither more or less likely. And I think once we get it all kind of going with this, what I'd like to be able to do is preserve these functions rather than just printing them out and being done with it. Preserve them, change where the targets are, and then see if the same functions do well. So now that it's learned how to find where the food is, can we change where the food is, and will the same one still go and find the food?
Well, by comparing the
So being
second
able
set
to-
of functions, or
being
by
able to
putting that function in?
Plug that function in to a stage where the food is in different places and see if, so basically use the best one as the starting function for a new stage where the food is in a different place and see if it's still able to find the food, even if it's where the food is different. So in other words, is it finding the food because it knows it needs to go 100 steps this way and then turn left and then go 100 steps this way? Or is it somehow seeking the food and going to it?
So we're trying to create artificial intelligence.
Yeah.
Is there a way to have all these functions just draw themselves at the exact same time? I mean, like, if we were playing a video game, you'd have different sprites doing different things all at the same time, so can all the turtles be their own little,
You could potentially make threads.
I don't know.
This is weird. Turn.
That's the bug.
That's the bug. I don't know what's going on there.
What's the
Extra
bug?
credit if we solve that bug? Sweet, thanks.
I think so.
That's what we're all gonna do this weekend. Solve the bug. Well, where's your project?
You know what that bug is?
Huh.
That's turtles with hemophilia. After a while, you just get cut on something, bam, done.
You should have put a smarter animal than a turtle.
See, it's not leaving out the left, it's leaving out the screen. So what we're seeing is it's coming out of the screen. It's a 3D representation. That's the z-axis we're watching.
So we actually have hundreds of turtles flying over our head right now.
taking it and experimenting on it.
This is quite a challenge for it.
It's getting a little better.
It doesn't like it, it's gotta see it like right at the beginning.
It's got two.
I think whenever they're in a straight line too, it's a lot harder.
Yeah.
Because the only way it moves is by circling around. So it's-
So you definitely need like circles.
But we just want to let biology take its course. And
Biology might take a long time.
Just speed up evolution.
Be a fish pretty soon.
Might want to work like some signs in there, just for minor turns.
So if you let this sit for a while, would it create its own AI?
take over the world. Start writing your Java programs for you.
Can't wait. Easy day.
So that maze video that you posted the other day for
Yeah.
discrete, how do they like program the mice? Is it something like this, or to run through the maze to know how to solve the maze?
Well, it's doing shortest path, basically.
Okay.
So it learns where all the intersections in the maze are.
Yeah.
So it's got sensors front, back, and side, so when it doesn't see a wall to one side or the other, then it knows it's at an intersection, and it records how many real rotations it took to get there, so it can know what the coordinates were. So it's learning where all the intersections are, and then it just does the shortest path algorithm on there, once it learns all the intersections.
So it just uses Prim's algorithm?
Dijkstra's.
Alright, Dijkstra's?
Yeah.
Alright.
So it knows where the beginning and the end is then?
Yeah.
That's cheating.
Well, it knows where the beginning is, because that's where it was set. It discovers where the end is.
Oh, okay. So you know why all of your turtles are retarded? Because their family tree doesn't fork. Yeah, how many tangents though?
At least we're down to under 200 now.
The tangent of the tangent of the tangent of the tangent
Of the log.
of the log. Oh, it's
very
not a
short
very
function.
complicated function. There's no
Seems like
there's no decisions anywhere in there.
It's not changing at all.
So far, this one that makes the big circle is the best.
27 generations.
So if we were running this on a more powerful machine, would it go a little faster? Like
No.
drawing and all?
It's the drawing that slows it down.
Alright,
Can you turn off drawing and just do it from draw the best one of that generation and then draw the best one of the next
Potentially, you
generation?
could try that. You find a place where it does the drawing, and instead of, so the turtle can put its pen down, they can pick the pen up. Try just picking the pen up and not putting it down. See if that makes it go faster. I'm not entirely sure it will.
Only put the pen down when it's successful.
Yeah. Well, this is gonna go on a while. It's got a, oh, hey, look, we're getting some mutations in there. Unfortunately, it didn't change how well it does. But we got something in there where it's now making decisions.
There's still too many tangents.
And these are just strange. It goes and then it, I don't know what that is. It just goes for a little while and then takes off.
Done?
Is it drawing lines between two points?
No, it's still.
Is that what we're getting? Because it could be that
Yeah, that
it's going to zero.
It's going to zero and they're drawing a line there, but I don't know why it's going to zero, because the only place where I say move is take one step. Why does it suddenly decide to take 1,000 steps and go over there? And there's nowhere in there to say like move to 0, 0. one of these tracks is a new turtle,
And so close.
and somehow instead of
Take a
actually
step.
creating a new turtle, it reuses the old one, and the old one moves back to 0, 0, and then it. So, we'll see how that goes.
Throw the snow
Okay,
in, yeah.
so you don't have to use the same operations that I've got. I happen to have add, divide, if positive, log, and tangent.
A multiply.
Did I miss multiply? Multiply. That's it.
Can I see your if positive? Is that the one where you split it into 3 different?
Mm-hmm.
Okay. Wow, that's
Oh,
huge.
wow.
Okay, never mind. No, I didn't want to see I just want to see the part where it's,
Oh, right here, eval.
yeah, return.
So it evaluates the condition. If that's greater than 0, it evaluates the true side. And if that's false, it evaluates the false side. And that's the thing it returns.
So the condition being the right leg, the true being the middle leg, and the false being the left leg.
Other way. The condition is the left leg. The true is the middle one, and the false is the right one. Although it's not really called left, middle, right. It's called condition, if true, if false.
So that doesn't really matter.
Yeah, it doesn't matter which one is which. It's just that the condition is one of them. The if true is one of them.
That's 3 things.
It just has 3 things. Yep. And that's why these appear to be longer, is because instead of having to have just 2 cases, there's 3 cases. Or if there's 2 legs, there's 4 possible ways that you can arrange those 2. You know, binary, 2 to 2. Once you get 3, now there's 8 ways. So that's why you get like all these ifs stacked up. Switch can't do like less than greater than comparisons. It can only do equal to. And even then, it can only do numbers and strings. How are we doing down here? Not any better. Wow.
I think we need to abort those turtles.
Go back to.
No, just give nature a fresh chance.
Oh,
You should
just-
happily like have an
Just come and extinction, start over again.
Extinction level event, start over.
Make a meteor hit it.
Like they can only live a certain amount of generations.
Yeah, I think you could maybe work some smart stuff, but like if the numbers just haven't changed in a few generations,
Start over.
just, wipe most of them out and start over again. Maybe keep one of them.
Yeah.
Keep like the one that was best so far, but otherwise just,
But if you keep the best one that was so far, isn't it just gonna try to do that continuously over and over and over again, so you get.
but you might randomly, so if you keep one of them, but you randomly generate the other 99,
Yeah.
chances are pretty good the other 99 are, maybe one of them will be a little bit better.
You're only gonna keep 4 of those, so you'll keep the cycle going.
Yeah, so
I think you have to do a major,
3 of the 4.
major replacement in the one. So you keep only 20% of the one.
Or,
Yeah, so you get to, I really want you to kind of fiddle around with how to produce the next generation, how to do the fitness function. And those are the 2 places where I kind of want you to mess around with it and come up with something better than what I got. Because it would be nice to be able to reward them for finding the food faster, and it would be nice to, make this number of generations like as little as possible, so it finds a solution faster. Change the mix of expressions that you have in there. Try throwing in exponent. Try throwing in sine and cosine and see if that changes things. One thing to keep in mind is that for all of the functions involving degrees, it's all, or angles, it's all done in degrees in this library here, so it's not radians. you guys need to do in order to fit yours to this?
We need to add
We need
get, replace, mutate,
Yeah, in order to be able to replace though, you need to be able to get
get,
and
Need to-
count.
add a lot of functions.
and then some kind of object or whatever. I don't know what that means.
The equals.
Yeah.
That was for the purpose of being able to do JUnit stuff.
Oh, for testing.
For testing. So
Okay.
I wanted to know if my get was working, so I had to set that up.
Alright. And then make your own scenario with what you're
Yeah.
gonna give us.
So it's basically, the first thing is get yours to compile with my program.
There you go. Oh, that's a good idea.
So it means your method names have to match up, what's being passed to them and what's being returned back has to match up. And make sure it works,
And then we can play.
then start playing around.
Would it be wrong to make it just draw a straight line? And if it hits one spot, then it goes straight line again to the next spot? Should always be the fastest way.
What do you mean draw a straight line?
He's saying, only put one dot, and it's like, okay, find the best fit for that dot, and then once you found that dot, go on to the next dot.
I'm saying like, figure out a way to make it draw straight lines while it curls and turns and stuff.
You don't want curls, you want to.
Yeah, it's.
Best fit of one.
What if we just had one thing for it to find?
You really cannot find that spot.
It's facing the wrong direction.
Give the turtle better eyesight.
I wonder if that line's real, if you put the dot on that line, it always goes up to the corner. Like, I found it first time.
Find it over to that.
I think some adjustment.
Boom!
I found it, it should be done. Oh, it's gotta go to the
It's gotta work through all the other 99 of them.
Maybe one's a little better.
Here's the one that worked. Nowhere in there is there any decision making. It just finds it.
Just lucky shoot.
Yep. So my guess is that with this one, if we move where the target is, it won't find it.
Wow, one generation.
Yep.
With a hook.
What if we just started our turtle at 0, 0? We could always see everything.
Well, it has a 10-degree field of view.
But nothing's gonna be behind it.
That's true.
Would you widen it up?
Widen the field of view.
Yeah.
Try that.
360.
360. See them all.
How would it?
They won't know which way.
Well, it has that strength. Actually, I lied to you about the strength. The strength isn't highest when it's in front. It's actually lowest when it's in front. So it's 0 when it's right at it, and that way we get a positive or negative. So it's positive if it's looking like to the right of it, and it's negative if it's looking to the left of it. So it actually, it's 0, and then it goes up to 10. So basically, it's how many degrees away from center are you?
So what
Makes
math
sense.
does it use to decide how to react to that?
That strength meter gets plugged into your expression, and that,
So that's probably why every now and then you get those expressions that just as soon as it like lines up perfectly, it shoots off.
yeah,
Because then you're like dividing by 0 or something.
right. Or you're plugging in 0, and if there's like an if positive in there, then suddenly that becomes false because it's no longer positive, it's now negative, and it decides to do something different. Oh, look at that. Some of them go this way, some of them go that way.
It's a positive statement then, right? That would be a positive state, then, if it, like half going top, half going bottom.
Yeah. So I don't know what should be about you, but I think this is a super interesting project. We're writing a program that writes programs, that tests them out, and then finds the best one. So imagine if you could write a program that wrote Java programs, try them all out, see which one worked the best for solving your homework assignment, and then you turn in that one.
That would mean that we would already understand 13 to its fullest extent, and we wouldn't need to take this class.
You understand 14, 15.
So you write a program that generates a whole bunch of random Java programs, compiles them. Well, first of all, it's got to see which one to compile.
I think Oracle would hire one of us to complete that. Like,
The hardest part is trying to get them to compile random stuff on there.
If you knew what the Java grammar was, you could make sure that you always produced a syntactically correct program.
Never make a mistake.
But it's so complicated.
But then what if you get
Go
one that
through all
just like
sorts of them
increments
before
high
it's
for
got one. Does it?
then it just crashes.
Well, you already know the Java program starts with the word class. So you have to put the word public class, generate a random name, brace, and then
we
what
need a
comes.
supercomputer to compute all the iterations that we would need to maybe create the right assignment.
You turn in this big convoluted program. You go, all it does is it adds two numbers together. There's a whole bunch of ifs, else ifs, and loops in there that basically don't do anything.
This is for your CS10 class. We're doing processing.
Don't they have contests for that, to make the worst program do
Yeah.
the simplest task, or was it?
What?
Yeah.
Most complicated program to do.
It's the hardest to
Almost
read.
nothing.
Yeah.
That would be it right there, is generate
So
random
if
programs.
you knew that that was the function, just add 2 plus 2. Yeah,
Find the most complicated way to do it.
randomly generate something.
But usually with those contests, there's a size restriction. So you have to find the most convoluted way to do it within 5 kilobytes of code.
I will put that
It's a lot of
parameter in my
code.
random function generator.
Usually it's more like 1 kilobyte. You get 1 kilobyte. But and sometimes it's do something remarkable with the Wilson-Dock code. So people have squeezed like an entire game of Space Invaders into 1 kilobyte.
That was cool for that site, yeah.
Yeah.
That was pretty cool.
How do they do that?
They tried it in JavaScript. I don't know.
Just call it a lot of crap.
Use very short variable names. Don't put any spaces in there. You can all avoid it.
Yeah, those just take up space.
Yeah.
I
It'll
thought
just be
I
one
thought
long
it
line
actually,
of code.
One long line of code. Yeah.
oh, in JavaScript, those spaces would count.
You can use semicolons to.
When the browser is the.
You can all be one line. Anyway, so this is just going to keep going. So putting food behind it. Oh, hey.
Well, it's just like
Happened to find
randomly,
one.
boom.
I heard that you're gonna close it.
It's like, we're just playing very.
That's motivation, right? Change.
Right.
Yeah. Change this to solve problem now.
On hover.
You just draw straight lines. Puts a point on your first target, puts a point on the second target, and it's done.
No.
Actually,
Output, yours just goes best and then puts out a random function here. But that must be the best. Clearly it works.
Well, and then it would draw the line and then move all the points onto that line.
There's a book out there if you're interested in learning more about this called has the word termite in it.
Google.
A book called Google. It's a book with all the information in the world in it.
Termites and mulch.
No.
Surprised there's no orchids.
you want to model a complex thing like forest fires or birds, bees, ants. Is an ant very smart?
No.
No, an individual ant, not very smart. But what does, so even it does have a little puny little brain, but what does that brain know how to do?
It knows how to sniff.
Talk to the hive mind.
There is no hive mind.
Just follows.
It knows how to walk,
Follows the person in front of them.
knows how to follow the person in front of him. How does it follow the person in front of him?
No,
They
that
have a
pretty
scent
small.
ant, another
It's
ant
got the
leaves a
scent,
trail.
right? So the one in front of him is dropping down little pheromones.
They can smell, carry, and walk. They follow directions
And
really
he-
well.
But who gives them the directions?
Direction giving ant.
our computer program.
Well, they've been found to be social climbers as well now. Just read that last week.
Well, so basically an ant kind of has three modes of operation. There's walk randomly,
No.
which is just kind of like go around,
Follow scent.
follow a trail, and pick up food. That's basically it.
When it's carrying food back to its hive, it automatically puts down a trail.
Yeah, so when it's carrying food, it's putting down a trail, and when it's not carrying food, it's walking randomly, or it can be following a trail. And so the idea is, all you do is you teach the ant how to do those four things: walk randomly, pick up food, follow a trail, or lay down a trail.
Does it
How
have
does
to
it
lay
know
down
how
a
to
trail
get
even
back
when
to
it's
the
looking
hive?
for food?
It follows the strongest trail.
What?
So if here's the ant and here's the food, then you get all these ants that are just kind of wander. They just leave the colony, and they just wander around randomly, and then at random, one of them encounters food.
We wants back.
So he picks it up, and he says, "I'm going to lead down a trail now." But he doesn't know where the hive is.
He follows
Follows
the
their
same steps back.
Well, he hasn't been leaving a trail.
Oh.
Yeah, they do. They leave a
Think
trail
they do.
when they walk too.
Oh, they do?
Yeah.
Okay, so they've been leaving trails, so he just kind of follows his own trail back, which means, he takes the long way around, which you've seen ants do, right?
Yes.
They'll take the long way.
And then everybody else.
But
goes
now-
down that path.
But now, basically, the same ant has followed his trail twice, so this scent is a little bit stronger. So now more ants are more likely to follow this path, and they start learning where the food is. If there's a whole pile of food over here.
But they also will eventually cut that distance down.
Because maybe one of them will randomly wander off, and then pick up the trail again and go, "Oh, well, hey, that was cool." They might do that. Sometimes they
It's like in that movie, Elite Balls. I don't know what to do.
And then when the food gets depleted, then the scent trail dissipates, and fewer of them follow it, and then they start finding another one. So all you got to do is teach the ants that 4 or 5 little operations, and then you say, "Give me 1,000 ants on the screen," and then you put piles of food around the screen, and they go and they find it and they bring it back to the hive. So nowhere in there did you teach them how to find food. You just told them how to pick up food and lay down a trail.
Now I want to go play Sim Ant.
So you get this sort of meta-intelligent organism that's made out of little tiny stupid organisms. And for things like forest fires, if you want to know let's say one tree ignites because of a lightning strike, and you want to know what percent of the forest is going to actually burn down if we don't do anything about it. What are the factors that influence how much of the forest burns down?
Wind, dry.
The distance between each.
The distance between the trees, primarily. So if you have a really dense forest,
It's all
the whole thing's going to burn down. If you have a really sparse forest, it's only going to spread to a couple trees before it finally finds a gap that's too big for it to jump, and it can't spread at all. So where is the threshold between the whole forest burning down and basically none of it burning down? And it turns out there's a really thin line. So if you have, I don't know what the exact number is, but if you have the average distance between the trees is 10 feet or less, the whole thing is gone. But if the average distance is more than 10 feet, basically none of it will burn down, just an isolated little patch. So it's not like you know, less than 10 means the whole thing will burn down. 10 to 20 means 50% is going to burn down, and then 20 or more means none of it's going to burn down. It's really kind of like less than 10, the whole thing, more than 11, nothing. It's strange. So you can run those simulations using that. It's kind of the same idea here. Is what we end up with here is a function that itself is not terribly smart, but it goes and finds the food. And we didn't teach it how to find the food. It taught itself. So I think that's cool. Yeah. Go on and do upper division work, and you might get more chance to do that kind of stuff.
I think it's a binary, like our biology teacher.
Yeah. Okay, so I'll post the latest version of this file here, and so your goal is to get it kind of all together and get it finding food.
So what's due on Monday?
What?
What's due on Monday? Or is that gonna change?
We don't even have class on Monday.
Well,
Yeah, it is. It's gonna be